All right, folks, thanks so much for joining us and being patient as we get started here. So I'm Travis Sturek. I'm a product manager here at Peplink, and today we're going to talk about from zero to hero, basically taking an impossible connectivity situation to a super happy customer. And to talk about this today, we've got a special guest with us, Peter West from West Networks. So I'll kick things off and kind of set the stage, and then we'll hand it over to Peter and let him talk about some of these situations that he's faced out in the field. So for those of you that don't know, Peplink's core mission, we want to make it always work. And we have a lot of products that go into a lot of different scenarios. And so whatever it is that your customer cares about, we want to make it always work. Not most of the time, not almost every time, every single time that they go to use it, we want it to work. And that's really what Peplink's all about. So today, like I said, we're going from zero to hero, right? We're taking these impossible connectivity situations and we're making them into just a happy customer, a great win. And so we'll start out and just talk a little bit about our technologies and how we're able to do that. And then we'll hand it over to Peter, let him talk a little bit more about how he's done this in the field and some different ways that he's done this, some best practices for how to go from zero to hero. And feel free to throw questions in there. I will keep track of the questions as Peter's talking, and then we'll tee those up at the end and let you guys get some feedback. So Peplink has some unique technology, and there's a lot of companies out there that make cellular routers, and there's a lot of companies that will throw around terms like SD-WAN, but when we really cut to the core of it, they're selling something different than what Peplink's selling. Peplink has truly unique technology called speed fusion. And so you'll see other cellular routers that have maybe two cellular radios, right? They've got two 4G radios or two 5G radios. But the thing that they don't really tell you is those two radios aren't really able to work together. They're only able to share the load. So one person's traffic can go on one radio, another person's traffic can go on another radio. And so what that does is if one of those two radios starts having problems, every bit of traffic that's on that radio also has problems. And so they're not able to react quickly to problems on any given radio. And so every user that's on that slow or poor quality line, again, their experience is not good. And so it has to actually share that traffic, and it's picking one connection or the other. It can't dynamically move it after it's made that choice. So that's load balancing. And at a technical level, that's called session-based load balancing. So your Zoom call can only live on one link or another. Your Teams call can only live on one link or another. Now with bandwidth bonding, we're able to do this at the packet level. So technically a superior way of doing it to the session-based. So within each session, there's lots of packets that make up that session. There's lots of packets that make up that Zoom call. And so with bandwidth bonding, we're able to split that out. So you can send half of the packets on one link, half of the packets on the other link. And if one of those two links starts having a problem, we can shift the next packets to the healthier link dynamically so that that application doesn't break. You don't have a period of degradation. We react within less than a second, move those packets to the healthiest links, and keep that traffic going. Now, when all of the links are healthy, you can add the bandwidth up. So even one single application can share the bandwidth of multiple links. Again, that's just not possible with load balancing. Each application has to live on one link or the other. And so it can't achieve the speed of both links on any single file transfer or video upload or applications like that. So again, Peplink Speed Fusion, this is really the difference maker. This is what makes these multiple connections really useful and able to solve real problems out in the field. Now, if we look at this from another perspective, let's just take a step back and just talk about failover. So again, there's lots of LTE routers out there, right? There's lots of companies that make cellular routers, and there's lots of companies that sell them as a failover solution. And so again, Peplink does it better. We've got Speed Fusion that makes the user experience dramatically different. And it seems like a subtle difference. We're both selling a failover router, but again, it's this extra layer of technology that we have that makes this so much more powerful. So if we look at a wireline scenario, pretty much every small business has some sort of cable DSL connection in there. And if that goes down, they're in trouble, right? Most of their business is done on the internet, so they need that backup. And so a lot of businesses have looked for a failover solution so they can fail over to a LTE or a 5G link. And so again, if they buy a product that isn't a Peplink and they set that up, what's going to happen? So they're using their applications, they're on their normal wireline, their cable modem, everything's great. But that cable modem has an interruption. So that cable modem goes down, and so what happens to everybody? All your Zoom calls, all your voice over IP calls, all your credit card transactions that are processing right then and there, those all stop, those all die. So all those sessions die. Again, taking it back to that technical level, all those sessions get interrupted, and then the router detects that and it says, okay, yep, that's not healthy. Let's turn on the cellular link. So then the cellular link gets turned on, and then you have to sign back into your Teams call. You have to call that person back on your voice over IP call. You have to rerun that credit card transaction. So it's automatic, but it's not seamless, right? And so I think that really takes a lot of people by surprise when they first experience that. You know, they bought a failover solution, they expect it to hand off cleanly, and that's just not the reality with most cellular routers out there. They can't do that in a seamless manner. And so again, this is what Peplink and SpeedFusion is able to do better. We can take those two links and we can fail over at a packet level instead of that session level. So those sessions don't have to break. Those calls don't get interrupted. Again, in less than 1 second, we can hand that traffic off so that you never have to log out or log back in. It's just a smooth, clean experience. And you can customize this. So you don't have to protect every bit of traffic on your network. You can say, okay, only the credit card machines matter that much, or only my Zoom or Teams calls matter that much. So you can define this at an application level, which applications get protected and which ones don't. So we'll talk about a lot of products today. There's a lot of different ways that you can implement some of the strategies that we just talked about, or the capabilities that we just talked about here. Oftentimes you see things kind of thought of in two different ways. We've got a field unit and a hub unit. So for SpeedFusion to work, you need an end-to-end connection, right? For us to be able to do this packet level technology, we need something on the other side to keep that session alive for the application. And so when we talk about the field, that can be a lot of different units, and we've got a handful of units here, but I would say it's not even limited to these units. Sometimes you'll see customers that really need great connectivity, and so they'll even use these EPX or SDX Pros as a field unit. Just depending on how much cellular bandwidth somebody's trying to achieve, that field unit can be a small, nice, compact transit duo, or it could be, you know, this 2U EPX. Actually, it wasn't totally intuitive on the front end that EPX could be a mobile field unit, but again, there's people that need that kind of connectivity out there. But nonetheless, whether you buy that small transit duo or that large EPX, you're getting those same SD-WAN technologies inside. So you've got that same capability. So again, big or small, we've got the power to make those applications work for customers. Now, the other thing that I'll bring up here is, you know, we say this is an end-to-end technology. So we've got, you know, you can build it yourself with physical appliances out in the field and out in a central site, or you can use our virtual machine Fusion Hub. You can put that in any cloud you want. Azure, AWS, Google Cloud. I mean, we just have not found a cloud that Fusion Hub won't run in yet, but even that is complicated for some users still. So now we've also got SpeedFusion Cloud, which can basically replace that second box or that second endpoint. Peplink hosts that globally around the world, so that you've got an easy couple click path to getting these great SpeedFusion benefits. So there, again, there's a lot of different ways you can roll this out, but nonetheless, every box, pretty much everything we sell, you're going to be able to achieve these same great results, just with varying degrees of bandwidth and different radio interfaces. So this is where I'm going to jump off and hand things over to Peter. Peter's out in the field doing this stuff every day, and so he's got all kinds of examples and bits of information to share with you folks and tell his story about how he's able to turn these impossible situations into real happy customers.
Thank you, Travis. So, and Travis hit on it right away, but you know, we talked about the SDX and you being used as a field unit. And what's interesting is as we started working through bonding and bigger projects, especially as we scale out with like mobile mammography and distribution centers and enterprise companies that are looking for high throughput, extremely high reliability in really weird locations, we found that antenna placement was really hard. And so, and the longer an antenna gets, the more loss you have. And so the idea here is zero loss antenna placement, right? So we can put an antenna anywhere and have zero loss with the HD1 dome. And that is what we have kind of came up with and started working on, is with the SDX or the SDX Pro and even the EPX, if you want to go that large, you can have, we can extend your antennas 300 feet away from the SDX or the router, the hub, the router unit in the field with the HD1 dome or the HD2 dome. And so that's really the power of this solution, is extending the cellular connectivity outside of a building, up a tall mast, on the top of a bus, without losing any RF loss, because the modem and the antenna are in one unit. And this all started with mobile mammography for me. And the idea, the challenge wasn't zero RF at the time, it was antennas. So if any of you have played with an EPX, well, the new category 18s are, and 5Gs are 4x4 MIMO. So an EPX with Cat 18s or 5G antennas means you have a whole bunch of antennas coming off that EPX going to the roof of a mobile medical clinic. And I needed to find a way to do that better, so that it wasn't so complicated for the end users. It looked nicer in the rack. And what I found out was, with the HD1 dome and the SDX Pro or the SDX, I could use a simple Cat 6 cable, and I would only need to have 8 domes or 16 domes. I could just have 8 or 16 Cat 6 cables cut perfectly to length, going right to the roof of the vehicle. And that's really how this whole project started. And then I started realizing that the SDX is a powerhouse, right? You're talking 12.5 gigabits of throughput. The SDX Pro is 24 gigs of throughput. And so taking that powerhouse router in combination with these SDXs or the HD1 domes created an incredibly powerful, high performing router solution out in the field. And so that's what we started doing. And the very first deployment we did was some HD1 domes on the roof, SDX Pro, and then SIM injectors. And we were able to feed the SIM injectors, the HD1 domes, via the SIM injectors. The SDX and the SDX Pro is a modular router. And so the SDX has 1 modular port, the SDX Pro has 2 modular ports, and the SDX Pro does have 2 power supplies. So we have redundant power supplies, 2 modular ports, and 24 gigs of throughput. So it's an incredibly powerful solution. And you can extend it with different modules. And you can see, if you look at this one LTA Pro, 1 5G module here, I mean, that's a lot of SMA or QMA connections that are there. And so, these modules get really dense very quickly. And if you're trying to do a whole bunch of these modules for high throughput needs, that becomes very cumbersome for the end users. And so, but then you also have the new SIM injector capacity. You have a 4-port SFP, 10 and 1 gigabit SFP. And then you also have the 8-port PoE and WAN-LAN. And it's important to know that the SDX, the 8-port switch on there is LAN only. The Flex module is LAN WAN. The SFP module is LAN WAN, and the cellular obviously is just WAN. And so we can extend the number of WAN ports as well. So think of like a balanced 2500, but modular and actually a little faster. The HD1 dome has a single PoE Cat 6 or RJ45 input, and then it has this really cool box on the bottom. And I apologize, Travis is a little bit more technical than I am. I more have fun with all this cool stuff. It has a little box in the bottom that actually splits that single input so that you can have an in and an out. And that's a Peplink magic there. So if you have a question about that, reach out to Travis. But basically, you can plug in the PoE input on that left input, on the left RJ45, and then you have actually a PoE output that can go to like a camera or something like that. I don't use that in these projects, but it's a really cool feature. The PoE input allows me to connect that right to the SDX or the SDX Pro for just basically a single cable. So it's super clean. The HD dome has 4 antenna modules inside. So you can either have 2 4G modems, right? So the HD2 dome with 4, because it's 2x2 MIMO, or 1 Cat 18 or 5G, which hopefully is coming soon, Cat 18 module that has 4x4 MIMO. So that's sort of the capabilities of the dome. And then you have the SIM injector. SIM injector, PoE switch with 8 SIM cards. So this allows you to, what's really cool is when you plug in a SIM injector directly into an HD1 dome, you have the ability to then have 8 SIM cards available to that HD1 dome. Or you can pull our cool design up here, and we can have the SIM injectors plugged into the SDX or SDX Pro, and then the SIM injectors are powering multiple domes. And that's where it gets really, really cool, because you don't need to have 10 SIM injectors for 10 HD1 domes. You can have 2 SIM injectors powering 10 HD1 domes. And it makes it much more convenient. It's easier for the end users. Once again, about simplicity, right? It's easier for the end users. And so I just did a project for Parkland Hospital in Dallas, Texas. And so we have 10 HD1 domes on the roof, 2 SIM injectors. That gives me 16 SIM cards. And I mapped the domes to the SIM injectors. And so that way, each SIM injector basically carried 5 domes, the way I programmed it. So really cool technology. And then the new, screen stop folding down. There we go. The new SIM injector 56 capacity basically takes the SIM injector concept, puts it right into the SDX Pro. Now I think this is really cool with an EPX, right? Because you have an EPX with the SDX with the SIM injector, and then you have a whole bunch of domes plugged in. But the SIM injector with the 56 SIM capacity basically simplifies that process even more by putting it right into the router. Best practices, just some simple best practices that I came up with doing this. This is actually a project I did yesterday where we installed some 10 HD1 domes on the top of a new MAMO unit. So I actually went up to Indiana and worked with the manufacturer to get them all installed. And so we had a lot of fun installing that yesterday and teaching them about this new design and architecture. But they actually asked me that, how do you know how many domes to use? And there's kind of 2 caveats to that, or 2 things I think about. One, how fast do you want something to happen? Like, how fast do you want to upload those images? Because in all reality, you could probably upload mammography images with 4 domes or 6 domes. So why 8 or 10? And that goes into speed. And the lady that was the customer for this already has 3 of these deployed. So 30 HD1 domes, 3 SDX Pros. This is their 4th SDX Pro and another 10 domes. So now this customer has 40. But she said it was really neat because they'll go out, they'll do a mammography, they'll do a scan, and if they have a potential positive result, she says, I can call the radiologist at the hospital, and by the time the radiologist pulls up the app on their computer, the images have already been loaded. It takes less than 5 minutes to send a 3D tomography, mammography, that's a really tomo mammography image, from the mobile unit to the PACS system in the hospital, so the doctor can look at that image in real time. And so the 10 domes enables that capability. So if we have 4 domes, it might be a little bit slower, maybe 6 or 7 minutes. And so that's how we decide, is how quickly do you want to upload those images? In the broadcast world, how many cameras are you trying to stream at one time? If it's a mobile command unit, how many field operatives are you trying to power? You know, are you just doing like 1 or 2 VoIP phones and a couple officers or field staff, or are you trying to power like a big facility, 25, 30, 50 officers? And so I calculate that, how much data am I trying to push through at the same time? And that's how I decide how many domes I'm going to do. And then it's choosing the right router, SDX or SDX Pro, and there are differences. The SDX has 1 flex module. So you can only have up to 8 domes max. So if you're gonna have more than 8 domes, you wanna have the SDX Pro. The SDX only has a single power supply. So if power supply, if redundant power is important to you, then you wanna have the SDX Pro, because it's dual power supply. You can plug that into your generator and UPS or however you want to set that up in your field operations. So that's how I make it. It's really simple. That's as simple as I make it. Are they trying to get more domes, or do they want redundant power? If they want more than 8 domes and they want redundant power, SDX Pro. And then SpeedFusion Cloud versus SpeedFusion, and it's kind of an ongoing thing. And I have this design. This is a design that we kind of a makeshift design. It's my master Visio sheet here, but this is an SDX dome project that I did for you'll see in a case study in a few minutes. But they actually have like this really good fiber internet, and what they were trying to do was hot failover to a bonded cellular solution, they didn't want infrastructure. They already had their VPN. It's a really big company, and they already had a VPN solution, and they wanted to add the SpeedFusion capabilities. And so this very large distribution facility actually uses SpeedFusion Cloud and the HD1 domes to create that. And so the way I decide between SpeedFusion Cloud and SpeedFusion is really simple for me. Do you want layer 3 access? Do you want inbound connectivity? And do you want to be able to talk between your sites? If the answer is yes, then you have to have SpeedFusion, right? We want to set up a Fusion hub or a hub router. So that way you have that in and out connectivity. SpeedFusion Cloud, if anybody is familiar with that service so far, we talk about 200 megabits of bonding throughput, but it's geographically distributed, zero infrastructure. It's phenomenal for companies that just want sub 200 megabits per second of throughput, what several of our clients refer to as dirty internet. And so that's the concept there is SpeedFusion enables more than 200 megabits of throughput, and it enables layer 3 routing or inbound connectivity like a static IP with port forwarding. SpeedFusion Cloud, dirty internet, 200 megabits of throughput. And so that's sort of how I decide between SpeedFusion and SpeedFusion Cloud. Oh, sorry. Okay. And I do have some use cases here. My very first ever HD1 Dome solution was built out with ANMED, the most patient company ever, because this was the first time we did this. And so we got the SDX Pro, we had our HD1 domes, and then we had our SIM injectors, and we worked through how to power them. When we first did this, there was actually no PoE WAN checkbox. It was a simple, we had to do a backend feature to enable the PoE WAN capability. And then we had how do we assign the SIM injectors via the SDX? And so, as everybody knows now, you have the a remote SIM agent and the remote SIM proxy capabilities of the SDX or the balance routers. That allows you to have a SIM injector behind an SDX or another router, and then send that remote SIM through to an HD1 dome that then treats that as a LAN connection. So that's the auto discover LAN. And so we had to learn all that with ANMED, and they were incredibly patient. They worked through with us phenomenally, providing us feedback and results. And they are uploading their images in under 2 minutes, to do a 3D Tomo image. It started to slow down. They were getting like 4 and 5 minutes, and everybody started complaining. And then I don't think they realized how fast that 4 and 5 minutes was, but they actually used up all their bandwidth and had some throttling issues. And we circumvented that with more SIM cards because of the SIM injectors. But the idea was that it was so fast, they were blown away that the capability of the HD of that bonding solution was able to upload images as fast as if they were sitting at the hospital. And that's amazing. First customer ever, and an incredible success. After that, we started doing more of these, and Yale New Haven is one of our, they're a really fun customer of ours. They've started out with a mobile mammography, and we're now doing all their COVID sites and their testing. And once again, we went up to Connecticut to do this project with them. They have 10 HD1 domes and an SDX Pro, and then we have we're using SpeedFusion site-to-site connectivity. So they actually upgraded their data center to 2 dual EPXs. So they have an EPX in one data center, an EPX in another data center, and then they're connecting the SDX to both of those data centers, and they're using OSPF and BGP to advertise those routes. And once again, talk about Peplink routers with the capabilities. It's not just an edge WAN. I tell my customers this all the time. It's an enterprise networking feature. So we're not just plugging into your WAN necessarily. Sometimes we plug right into your infrastructure. And because Peplink is an enterprise routing capability, we have OSPF and BGP and IBGP and GRE tunnels and BGP over GRE tunnels and all of these enterprise features that customers need to be able to integrate with their infrastructure. And whenever we come up with one of these roadblocks, Peplink just enables it, and then everybody gets it. So that's just, my little plug-in for Peplink there, but that's pretty freaking cool. Another mobile clinic, this one's 4 HD1 domes. And I really like the install here. This is University Medical Center of El Paso. 4 HD1 domes, SDX, not an SDX Pro, because we're less than 8. And so we only needed the SDX, 4 HD1 domes, and they're using SpeedFusion site to site to go back. And they got this really cool metal box on the roof, and so the HD1 domes aren't using that box. They're going right through the metal box, and then the Cat 6 cables are going directly into the domes. So kind of a different design, really clean though. I love the way the manufacturer put the box there. And after we did this, we were getting referrals from El Paso on the performance to other companies. I've been to El Paso now 5 times since deploying this, because they were so impressed by the capabilities of their connectivity on these domes. And they're using all the SIM carriers. So we have AT&T, Verizon, and T-Mobile being used here with incredible throughput. They're getting over 300 megabits of throughput on 4 domes, all over that kind of eastern area of Texas. This was a really fun one. I actually cut my finger off right before this, so I was a weird install. But not all of it, just a little tip of it. But so this is an aviation company, and they had a major outage of their core infrastructure. And he called me and said, "Hey, we need internet right now, and we need to be able to power our entire company." And so we grabbed some HD1 domes, drove down to, it was actually in South Florida, so it was actually remarkably close. It was only a 4.5 hour drive. And then we installed the domes on the roof of this building. That's my guy Tim right there holding some domes. We installed 5 domes, ran those down into SIM injectors, and then plugged into, because they actually wanted HA. So we ran the 5 domes down into SIM injectors. Then from the SIM injectors, went into dual HA SDXs. So we actually didn't use the PoE WAN feature. We used the SIM injectors. Each SIM injector powers each dome. And then that enables us to then plug each of the SIM injectors into the 2 SDXs. And once again, the reason for the SDXs, we have HA, so they didn't need redundant power supply, and under 8 domes. So we chose the SDX over the SDX Pro, and then used the SIM injectors to split that off into the 2 SDXs. An incredibly fun project. The customer the internet provided by SpeedFusion Cloud was faster than their internet they had at the building, and they were blown away. So once again, SpeedFusion Cloud saved the day on this project and brought this company back up and running within about 6 hours of an outage. So really, really fun project. This is a automated distribution center. And so this is the first one I did. We've done 5 of these now, and we're doing them all over the country. And so this automated distribution center needed redundant backup for their fiber line in the event of an outage. Because the entire facility is automated, they use AWS servers to control all their inventory and flow in the robots. And so they needed to ensure that in the event that the fiber line gets cut, or there's an outage of a particular carrier, they wanted carrier diversity and enough bandwidth to be able to continue to operate the facility in the event of the fiber outage. Only they traffic shape it on their end. Only the automation functions process over, or critical business functions go over the cellular. So any other guest networks and things like that all shut down in the event of a fiber outage. However, they were actually, in this particular one in Pennsylvania, we were getting over 300 megabits of throughput when we connected it to a Fusion hub. And then with SpeedFusion Cloud, they're getting their 200 megabits, and they were more than pleased with that because they only needed 100 megs. But we're in a very rural mountainous area, and we were able to aim that dome at a tower, and then we had 2 Omnis because there were some towers around, and they were incredibly pleased with the throughput. So much so that we're now doing it to every single one of their distribution centers in the country. We also have built these out for broadcasters, and I can't really talk about which broadcaster, so we have some generic pictures here, but one of our broadcast customers is actually bought they're doing 8 HD1 domes. So we have 8, so it's not over 8. So we're actually doing SDXs. So it's SDX with 8 HD1 domes, and they're using this to do all their broadcasts of multiple cameras. The HD1 dome provides the ability to spread the antennas out outside of a building better than running like LMR 400 or some really thick, a bunch of Ethernet RF cables. So they get that zero loss connectivity out of a building up to the top of a roof. We actually had a customer, the same customer, call us and say they had an emergency need because of COVID in California to spin up a site, and we mailed them a loaner unit because they were an emergency. We mailed them a loaner unit. They spun it up and they ran their entire broadcast for 2 months over 4 HD1 domes and an SDX. And so the capabilities to be able to pull these antennas, these routers or the antennas out of a building to reduce interference in a building and increase throughput is a game changer for this industry. And then the fact that you can go 300 feet, on PoE, it gives them better length, better capabilities, and it's really, really easy. You don't need an RF engineer. You can just plug in a Cat6 cable to the SDX, plug a Cat6 cable into the HD1 dome, and you're up and running. And so they're streaming multiple cameras at the exact same time over SpeedFusion, going directly into AWS. And then the picture on the left is more of just a funny one, but that's a project we made for as a remote field kit. And that's actually not being powered by domes. That's being powered by an MBX, but still pretty cool. And now I'm available for questions and answers. So if you have any questions, or if you've asked those questions to Travis, then we can do that.
We got a couple questions teed up here in the chat. If you got questions on your mind, throw them up in there and we'll dig through these and get to as many as we possibly can. First up here, I see question, what would be the target upload and download speeds if you're using 10 domes? What kind of speeds have you been able to achieve with that kind of setup, Peter?
We've had some pretty remarkable speeds that actually exceed the limits of Peplink's posted speed. So I'm going to limit it at the posted speeds of 500 megabits of upload throughput. So we have achieved 500 plus megabits of upload throughput. And I've achieved that with less than 10 too. So it's not about the 10 is really about density and coverage, right? So what happens is, like, I'm sitting in a Home Depot parking lot right now in northern Georgia, and I have my Transit Duo. I keep it with me all the time, and I'm getting 75 megs down and 40 up right now. It's phenomenal. That is not the case everywhere you go, and I think that's the common mistake that people make when they're trying to build out a solution. You don't get 75 down and 40 up everywhere. Sometimes you get 4 megs. I got a guy called me yesterday with an MBX getting 2 megs on Verizon, and he had 4 Verizon SIMs. I said, hey, go get an AT&T SIM and plug it in. He went and got an AT&T SIM, plugged it in, and he was getting 35 megs. And so, the carrier diversity is incredibly important, but also you're not going to get that throughput everywhere. And the 10 SIM cards is not about maximum capacity. And I don't even sell it as that. When I'm selling this solution, I never advertise maximum capacity. I advertise expected results. And that's what we promote. That's the engineering solution. Because when you advertise maximum capacity, even though I could demo every day of the week that I can get 500 megs on 10 domes, that's irrelevant when a customer is in rural Nevada or up in Arizona and they're getting 3 megabit circuits and they just can't get that. Then they feel like they've been misled. And so my solution is always based on expectations, and it's always based on meeting the job, not the capacity. However, that being said, phenomenal capabilities. I've seen it. We hit well over 500 megs on one demo, and it was really fun, and everybody took pictures of it.
Yeah, everybody loves to run speedtest.net and just bury that needle, but I like the expected results, because I think that gets back to, what is your problem? What are you trying to solve? What do you want your day-to-day look like? And it sounds like that's really the path you take.
That's my only sales strategy, actually. If anybody's out here as a salesperson working in Peplink, like, it's all about the results. It's not about a speed test answer, because it's going to vary so greatly. You'll always disappoint them if you sell them on throughput.
Mm-hmm. Very cool. Okay, so another question here, and I think this ties into what you just talked about. I wish I had the I wish I had the answer for this question, but you deploy this a lot, so maybe you've got a good answer here. So you talked about managing bandwidth across multiple SIM cards, and so I think number one, I think that's just an important thing to talk about itself. I mean, I think a lot of people think of a SIM card as kind of a one-to-one thing, right? I've got one SIM card for one device, and so how do you see the SIM injector playing in the management of that bandwidth versus just having that carrier?
So that's a catch 22, Travis, because I posted online, and I've actually intentionally didn't talk about a few of those during this presentation, because there's the officially right way to talk about that, and then there's the what people do in the real world. And so but that being said, the
I like to
SIM
live in the
injector,
real world, man. So
yeah,
it's all for the game.
so the SIM injector, right? When you're talking about bandwidth management, the SIM injector plays two key roles, and there's a couple ways to fail over SIM cards, right? I can say fail over a SIM card if the signal strength is less than 2 bars, right? Or I can say fail over a SIM card if my internet fails, right? T-Mobile isn't available, it fails over to AT&T or Verizon SIM. And then I can say fail over if I've hit a certain bandwidth limit. So if I have a Verizon unlimited plan that's 22 gigs, and I want more than 22 gigs, but don't want to pay their fee, right? I could have 8 Verizon SIM cards and a SIM injector that fail over at 22 gigs. And so that's where when we talk about capacity management, we can use the SIM injector to inject more gigabytes, right?
Mhm.
It's not only megabits per second, but it's gigabytes. The SIM injector provides gigabytes.
Yeah, per
And,
month or
and it,
for whatever your time
exactly.
period is.
And that's one of the, outside of being able to have one SIM injector power 8 domes. Alternatively, one SIM injector provides a lot of gigabytes, and that's powerful in today's world when we talk about Netflix and Zoom meetings, and the ability to. I've got a customer right now running over 4 terabytes of data on 8 domes right now. Terabytes, not per month, and so. And we're doing that using the SIM injector and gigabyte management. I'm gonna call it gigabyte because gigabits per bandwidth and capacity and throughput all get mixed and matched. But
Yep.
so the SIM injector can either provide us resiliency, it can provide us scalability, right? It can multiple domes, one SIM injector, or it can provide us gigabytes. And those 3 categories is the power of the SIM injector. And this new 56 bay SIM injector, I mean, now you're talking even more capacity, more gigabytes, and it's getting better. So
So not
I
only are
hope I
you
answered.
yeah, you definitely did. I mean, not only are you diversifying the carriers you're using, but you're diversifying like the buckets or plans within that carrier. So you're basically
Exactly.
not getting throttled, is what you're trying to achieve there. It sounds like.
Correct.
So this is, I'll be the first to admit I don't know everything about Peplink. I know like one person maybe that I could say that does. But this is a question I actually had asked to me just a couple days ago. Are we able to manage that bandwidth allowance monitor feature on those SIM injector SIMs now? I know previously it was kind of only visible for the SIMs that were plugged into the unit versus on a remote SIM injector. So is that a feature that we've actually turned on for you yet, or is that yet?
No, that feature actually with the SIM injector is not.
Okay.
It's coming though, right?
Yeah. So I know we've got another kind of layer of software there. It
Yeah.
turns out it's complicated, right? To manage all
Well,
these SIMs.
and you have a whole bunch of SIMs that could flip flop, right? So if you have the SIM injector and you have SIM slot 1A and then slot 2A, if they swap the SIM card, is that now where does that 22 gigs? So we need a platform that can manage the ICCIDs and the bandwidth used per ICCID. And I think that is something that will be really cool. I don't know how
Yeah.
else to say. So
Yeah, that's fine. So, I mean, there is another layer of software that we're working on in the background to add a lot more intelligence to these, multi-radio, multi-SIM, these really kind of massive deployments like this. And so it kind of has to take a step beyond the router to really make sense of all those different pieces that are kind of separate in some ways. But yeah, I mean, I think you've seen the software as well. We've got a Fusion Sim Cloud that's going to be able to manage these SIM cards in much more intelligent ways and much more scalable ways, really. So, Eliza, your question, it's not quite there, but it will be available in another format.
Yeah, and it's going to be awesome. You're going to love it.
Yeah, and again, I mean, I just think it's so important to really triple down on this, that it's not just about having more SIMs, more radios at the same time. It's, managing those data buckets, especially, if you're uploading these huge files, if you're broadcasting constantly, it's just, rotating through your different carrier plans is really challenging. I mean, we have carrier reps asking us all the time, like, hey, this customer just keeps burning out their data plans, and I don't have a way in my system to give them more data. And so, there's lots of people trying to solve these problems, even though they may seem out of reach for some folks. Okay, so another question here. Why use so many domes and not use an HD4 MBX with just 2 domes? And I guess first thing I'll say is that is a valid combination, right? You can do it that way.
I actually have a photo of that. This right here.
Okay, yeah.
Yeah, so this is an MBX that I deployed for a company, and you see those 3 Ethernet connections right there, coming off the WAN. That's 3 HD1 domes connected in. So that's an HD7 in a sense, is what I kind of called it in my network design.
And I know my answer. That is number one. That's a valid setup, and in some cases that may make a lot of sense. But I think it depends on how far away those antennas are. Sometimes you're just adding capacity to an existing MBX, and that makes perfect sense. But if it's a greenfield installation, like LMR 400 is $1 a foot, and that MBX you saw there's 16 antenna leads for those LTE antennas. So it's $16 a foot to get outside to your antennas. I mean, it doesn't take too many feet to really start adding up a lot of money there. And so, I mean, that's my view on why you might think
the other thing, Travis, is this is actually not more expensive. The SDX is a base cheaper product. It doesn't have the integrated SIM cards. So an SDX with domes is not necessarily more expensive than an MBX. And then I get a lot of these questions a lot, and I'm going to hit this one a little bit just because we're on a webinar and it's going to be fun. But I get people all the time, can I buy a transit duo and then plug a transit into the WAN port of that? The answer is yes, right? The answer is yes, you can. But then we talk about scalability, capability, and support. And so when you have a platform like the SDX with the HD1 domes connected to it, I can connect into that SDX. I can manage those HD1 domes, and I can see everything that's happening in that network right there. And so you have a lot of DIY guys out there, or DIY people, I should say, but a bunch of DIYers out there that yeah, you might be able to build that solution out. But when you talk about enterprise scalability, when you talk about resiliency, when you talk about making it to where it's easy for the customer, you want to build a solution that is predictable. And the SDX provides that. And it's critical. When I get these customers and they're asking me, I did the demo yesterday when I did this install up in northern Indiana yesterday. I was showing the guy how we built this infrastructure. He's like, oh, this makes perfect sense. It clicked right away. If I had a whole bunch of BR1s plugged in to an Ethernet connection with a whole bunch of power supplies, yeah, it might be it would probably work. It might actually be a little bit cheaper because the BR1's cheaper than the HD1 dome, but that's not the point of that project. And then the other thing is the HD1 dome specifically over like a transit. The whole idea of that over the MBX is zero loss. The whole purpose is to eliminate the super long antenna cables and the number of antenna cables. So it has a very specific use case about eliminating RF and simplifying cable management. And so that's why it's so much more powerful to do that. But it's also not actually more expensive. So it's sort of just a decider of which platform you like better.
hmm Yeah, I mean, I could understand, in a small vehicle, if you're just running them 10 feet up to the, from the trunk to the roof, the RF cables aren't that big of a deal. You don't have that much
Yeah,
loss, but
correct.
the bigger the bigger the vehicle, the bigger the number of connections,
Yep.
it starts
Yeah,
to
and
it's
I
just
install way more. I install way more MBXs with 4 antennas than I do SDXs with 10 HD1 domes. This is, a very specific use case here. I mean,
Mhm,
I'm sure I install 10 MBXs a month that have, MBX with the mobility 40Gs versus the HD1 dome and SDX. But
mhm.
these are cool looking, really, really cool looking. So
Nice. Another question here. How do you see the range of the HD domes compared to a typical Omni?
it, it's about the same as a mobility 40G. I'll keep it into that realm. I
Mhm,
see the coverage and range to be about the same. What I do, what's nice about it is you're not sacrificing that signal quality for the
mhm.
dome. Now, obviously, if you were to install like like the new high gain, come on, Travis, the marine antennas. The
Yeah.
new high
Yeah, the
gain marine,
maritime.
yeah, they're going to get a better gain than a dome. But when you're comparing against the nice rooftop omnis, it's about the same. It's
Mhm.
very nice, and they work really well. And when you're comparing them to those same platform.
Yep. Yeah, and I think some of this comes into it's kind of technical hair splitting, but I think it's important to understand for people that the RF cable degrades the signal, right? The longer the cable, the more signal that you kind of rob from that antenna, right? So the antenna is going to boost you up 6, 7, 8 dB, and then the cable's going to take away
Drop you
one, two,
down.
three, four. So you're
Yeah.
you're kind of like 2 steps forward, 1 step back, and depending on how much antenna you've got, you can take more steps backwards than forwards sometimes. But that impact is even greater on the higher frequencies. So 5G is being rolled out. It's not a lot of the times the speed is just because there's more high frequency bands that they're throwing in there, and so that coax will impact those fast bands a lot more than those low frequency long range bands. So yeah, I mean the range, you're probably not going to see a terribly big difference in the range because those low frequencies are going to carry through the antennas fine. But I think you're going to see an impact in speed, especially as 5G gets more and more prevalent.
Yeah, and I 100% agree with that because the high frequency connections, and you got every meter, right? Every 3 feet of cable is lost. So
Mhm.
if you're, that's what's actually really nice about the mobility 40G and the way Peplink's done that is you have that 2 meter cable. So you're keeping it within the realm, and then it keeps that cable nice and short. And you have the QMA connectors goes right in the back of the MBX. It makes a very clean install.
Yeah, somebody who probably plugs in more antennas than anybody on the line here. What do you think about the QMA versus the SMA?
I love it. I know it's what's nice about it is, and you travel around, and I do installs every week. So I got 4 more next week, and when I go to do service on these things, SMA, it vibrates loose. Even if I do a little bit of Loctite, which I've tried, it just doesn't stay on there through in the long term. The QMAs, every single time I go on, guess what? It's still there. It locks in. It's vibration resistant. It's rotation resistant. You don't have to worry about it falling out. So, and when you talk about the density of the 5G and the Cat 18, you physically can't get your fingers in there anyway. So I
Mhm.
love the QMA connections. I know it was a big decision within Peplink to choose that path, but from someone that installs a bunch of antennas, it's incredibly very nice.
Yeah, I mean, I know QMA is a little bit more expensive, and it's just, nobody has like a whole cache of QMA connect drive stuff yet, just because it's a newer thing. But yeah, I agree. We made that choice because it is just flat out easier to install, and especially as these densities get higher. And so glad to hear that's beneficial in the field. Let's look through the questions here. So one question: what can you say between the latency of different providers and SIM cards, and how is SpeedFusion managing this? So, the thing I'll say is SpeedFusion just basically picks the path of least resistance, right? And we put more packets in the paths that flow easier. And so, if one connection's latency is going up, 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 we're going to send less packets that way. And there's cutoff thresholds you can define to kind of structure that behavior a little more. But I guess that's where I'll leave it. Peter, I don't know if you can comment on managing latency variations.
It's probably the single biggest challenge, latency and packet loss, right? Latency and packet loss are the two largest challenges that affect bonding throughput. High packet loss on any individual SIM card is going to cause a bunch of problems. And Peplink has done a good job of mitigating this, right? You can modify your SpeedFusion tunnel to cut off or suspend circuits that have high packet loss. But you also have in SpeedFusion configuration capabilities, you have the ability to set the differential of latency. And so if you don't take into effect WAN smoothing and FEC and all the other technologies, if you're talking about just pure bonding, there's two ways to mitigate easily. One, you have the packet loss suspension timeout. It's under the advanced options. And then two, you have the latency differential. I find those really neat for plug and play solutions because you don't want to sacrifice bandwidth in slow and low bandwidth areas because you're trying to mitigate packet loss or latency in one specific area. And so usually most of my customers are mobility customers. And so there's not a one size fits all. So I try to make it to where it's as close to that as possible. So enabling WAN smoothing as a default for just bonded internet to circumvent packet loss of when someone's looking for high throughput is dangerous because you're sacrificing bandwidth for that capability. So Peplink's fixed that a lot. The other thing is can I mention DWB?
Yeah, absolutely.
Okay, so Peplink's implemented dynamic weighted bonding. It is currently a hidden feature, but if you have not heard of this, I have a YouTube video that we're publishing on it. So you're more welcome to go to my YouTube channel and check that out. But dynamic weighted bonding almost completely solves that problem, especially when it's latency related. Dynamic weighted bonding is their new bonding algorithm, and that takes latency and packet loss and jitter into account as it creates the bonding. And what's really cool about DWB when you start to play with it is, like, say you do a speed test with DWB enabled or without DWB, and let's say you get 22 megabits of download throughput, and then you enable DWB and you run a speed test and you get 22 megabits of download, and you go, wait, it didn't make it any faster. DWB is constantly analyzing the throughput of the SIM cards. So you do one SIM card throughput speed test and you get 22 megs of throughput. You do the next speed test and you get 60 megs, all the way up to this record-breaking performance that we just got with somebody that was well over 500 megs. And so DWB, what it does is it monitors the capacity being used and then dynamically allocates that throughput. And there's some special math that SpeedFusion has done to make that work. But the idea is when you have variable latency or variable throughput connections, bonding doesn't work great. You have a 1 gigabit fiber line and a 10 megabit DSL, you're gonna not get a great bonding. You're not gonna get that 1.001 gigabits of throughput. And so what DWB does is it helps mitigate that when you're talking about 5G versus 4G and popping between 5G and 4G connections. You'll see that your 5G connection can get 186 megabits of throughput, and your 4G connection is getting 32 megabits of throughput. Without DWB enabled, you'll see the 5G connections getting 45 or 50 megabits, and the that 4G is getting 35 megabits because the differential that's required. So DWB is going to be a big change, and I think you're going to see that in the next firmware or so. But I'm publishing a YouTube video on how to enable that. But that's how we mitigate. And then you also have the cool Peplink technologies, FEC and WAN smoothing. But just without those, just cool regular bonding, Peplink does a great job at mitigating that, which is awesome in my opinion.
Yeah, the dynamic weighted bonding is great, and that we've kept that as a quiet feature. I mean, because in reality, we've been working on that. I say we. Steve's been working on this algorithm for years. I get to stand on the shoulders of giants here when I talk about Peplink technology, because there's some pretty awesome stuff going on in the development side. But but yeah, that dynamic weighted bonding, I mean, just like you just said, I've seen similar things where I was testing with a customer who was trying to bond CBRS private LTE with their Wi-Fi network. And their Wi-Fi network, they could get 250 megabits of throughput through that. The CBRS network, they could only get like 20 megabits of upload. So it might seem kind of trivial to add 20 megs to 250 megs, but for them, it's just, like you said, it's 2 minutes versus 5 minutes can feel like a long time in their day to day. So every little bit helped for them. And, the previous algorithm didn't do a good job of managing very wildly different speed links,
Yeah,
right?
we call it
And
disparate links.
yeah,
You have disparate links, DWB really kicks in and saves the day.
yeah, so I was able to see, 270 megabits when you add those two up, where before it would, be 250 or even 240, with the older algorithm. So it just seems to do a
Yep.
much better job with those, and that's the reality that we find. Like you said, pick a carrier, right? Everybody's got their dead spots, everybody's got their congestion. And so, your fast carrier today might be your slow carrier tomorrow if you're moving around, and or not, right? Just traffic patterns in a stationary location. But yeah, being able to dynamically, hence the D and DWB, react to those changes is where I've seen the biggest improvement there. But yeah, I think in the next major firmware release, we'll actually kind of pull the curtains off that and put that proper in the GUI, so you don't have to enable that. But it's there. If anybody's got SpeedFusion on their router, you can turn it on. Just turn it on both sides is what I'll tell you. If it's to SpeedFusion Cloud, we'll
Well,
recognize it. But
yeah. And if you're using in control SpeedFusion, literally just check that box that says advanced features and you'll see dynamic weighted bonding. It's by far the easiest way to turn on dynamic weighted bonding. And if you're not using in control, if you're a legacy or an older person that and that, and by the way, I'm speaking to myself, FYI. So if you're a legacy Peplink user, it has a whole bunch of manual SpeedFusion profiles. You should play around with SpeedFusion and in control. You get all these advanced features, all these the buffer latency I was talking about, the cutoff latency, the packet loss latency, the ability to manage your WAN circuits, the ability to turn on DWB. It's a checkbox on in control. So you can go through the GUI and go to support CGI and enable DWB, or you just check a box. In control is really, it's stepping up their game on management of SpeedFusion profiles to a point that it's become my default go-to versus my backup go-to. And it's simply, if you go to SpeedFusion on in control, click advanced features, and you can just browse those advanced features right there. So it's very easy to see and enable that DWB right from in control.
Nice. Yeah, that's a great point, because yeah, I mean, I think a couple of years ago there was kind of there wasn't really parity, right? There's a lot of new features in SpeedFusion that weren't in control. And so,
Correct.
myself, I found myself building a lot of profiles manually. And, it's important to remember, like, we have addressed a lot of that. So you have those features now in IC2. And yeah, you're right. It's just a lot easier.
Exactly. And now the development team is pushing that out faster to in control too. So you're getting that, you're not having to wait for that feature to come out. It's really, really nice.
Yeah, it's one of the things we like to do is listen to our customers, right? A lot of people were screaming about it, and so we did it. We hear those requests, and so yeah, keep it up. If there's something you folks out there are looking for us to do, just put it in the forum and get some votes on there, and the engineers do see that. Okay, I know we're over the time here, but I got one more question that I'm going to take just because I think it's a fun one. For extreme connectivity where you don't have any network, have you tried bonding multiple VSAT links with the same latency? We tried bonding 3 similar VSAT KA wild blue like links on a balance 380, but they found it wouldn't really bond all 3 and would only pick one. So I can say, I don't know on that exact situation what the problem might have been, but I've got some speculation I can throw out there. But I took this question because it really goes back to the absolute origin of SpeedFusion. The first customer I remember working with, this was over 10 years ago. They were a 3-letter agency government contractor, and they were trying to bond 2 satellite links for these remote outposts. I don't, it's one of those don't ask, don't tell. We don't know what they're doing out at these sites, but they needed to bond 2 satellite links to get more throughput for their application. And that was really one of the first Speed Fusion deployments we ever did. And so it didn't work great right away, but just like always, we don't give up. And so we got it working very well for them. And that was, again, a early major Speed Fusion deployment for us. Now, Peter, I don't know if you've ran
I,
into these bonding satellite
I've
links out there.
we have, and it's important to understand the difference between a dedicated fiber satellite link and a shared satellite link. So if you're using like HughesNet or any of these shared ones, a lot of times they burst, and that completely stops the ability to do Speed Fusion. You cannot bond successfully or reliably like a HughesNet and another HughesNet or another satellite, because the way the base technology. Now, I've seen people try it and quasi work, but so I'm not saying you can't do it, but you can't do it reliably. I'm going to add that reliably word to it because it's important. But we've had huge success bonding dedicated satellite circuits, especially with DWB. And I can't really go much more into that, but as long as they're dedicated bandwidth circuits, yes, you can. If it's a private or shared or bursted service, you got to be careful about those. Not private, but if it's shared or bursted, those take time. It's like cellular, but 10 times worse, because they're time sharing the frequencies available, and so you're fighting for the same frequency on the Speed Fusion. So you're basically load balancing those connections over Speed Fusion versus actually bonding over Speed Fusion. So you're increasing the amount of time you have on the satellite, but not the bandwidth. But if you have a dedicated frequency, then you can successfully bond it.
Yeah, I think that's a good point, because I think that's similar on the LTE side, right? If you've
Correct.
got
Yeah.
4 SIMs from the same carrier on one tower, you're going to get 4 more time slices, but that's not going to 4x your throughput. It's going to
Correct.
be an incremental improvement at best.
Well, what it does, it gives you more slots of that bandwidth, right?
Mm-hmm.
So the customer I had just yesterday calling me complaining was in a building, Verizon, all on band 13. So 4 SIM cards, MBX, and individually I could get about 4 megabits of download throughput on each one of them. So each SIM card individually, but bonded, I was only getting about 6 megabits of throughput, because all we were doing was sharing those time slots that were on the band 13. So we weren't able to increase. And the same thing with satellite. When you're sharing the frequency or sharing the time slots, what you're doing is improving the number of time slots you have, not combining the bandwidth. And that's really important with cellular. And then it's exaggerated greatly with satellite. So as long as you take that into account, you'll be okay.
Yeah, and I think, it's good to point out too, like a 50% improvement in throughput on that 4 meg to 6 meg thing. I mean, that's still a really big deal, even, so I mean,
Exactly.
there are benefits there, but just not as dramatic.
And then the other thing, and I open this, I'd like to add one more just based on that. And I know we're over time, but it was super important to realize, and I talked about this at the beginning with expectation, is with cellular, what we're trying to do, especially with 10 or 6, I've done one with 21 SIM cards. When we're doing that, we're not trying to get gigabit throughput. We're trying to get more slices of the pie. And so it's important, if there's only 3 carriers out there and there's only so many towers around. So when I'm combining 10 SIM cards together, or 12 SIM cards, or 16 SIM cards, I'm not trying to go from 250 megabits to a gigabit, which I've done, but that's not the point of it. The point is I want that 250 more often and more reliably. That's really what I'm trying to do, is I'm trying to create stable, reliable internet. And so if I have got 2 SIM cards that are sharing slices of that pie, even that Verizon customer from yesterday, he's going to get consistent 6 megabits of throughput versus 2, then 3, then 4, then 2, then 3, then 4, as it rotates those slices of the band that he's sharing. And so that's what we create, is consistency more than aggregation, especially at the high volume of the same SIM carriers.
Yeah, I love that consistency, because I mean, it's like, okay, if you take take your jetpack or your MiFi device out there in the field, and you might hit 120 megs, one time of the day, but then you might hit 20 megs another time of the day, and
or 2 megs.
Or 2 megs, yeah, exactly.
And so
And so
that's
yeah,
the exact issue is, and everybody that does broadcast, especially the broadcasters, know this pain, right? You go out there, you have your hotspot, you do your speed test, you get your 80 by 20, and then you start your broadcast, and 3 minutes into the broadcast, it drops down to 15 megs, and then maybe an hour into the broadcast, they're running 6 megabits. And so what they're doing is that bandwidth is being shared among the towers, among the people on that band. And so
mhm,
the consistency that we get by combining is more important to these customers than just a speed test that gives them a gigabit of throughput.
yeah, yep, absolutely. It's easy to look for that speedometer maxing out, but that's not what solves people's problems oftentimes out when they're
Yeah.
trying to do work in the field. Well, cool, Peter. I'm super appreciative of you spending your time today. And just for those of you that did not hear it, Peter did this whole webinar from a Home Depot parking lot on a Transit Duo. So, I mean, that's what I just love is like, this is the type of stuff you can do with our products. You can confidently do that, not have any issues, and it just works. So thanks again, Peter, for taking all the time to share your experience from the field.
Thank you. And everybody have a great one.
All right, take care, folks. Goodbye.